Number 17 on page 337, the problem says, a ladder 20 feet long leans against the side of a house. The angle of elevation of the ladder is 80 degrees. Find the height from the top of the ladder to the ground. So in this problem we have a ladder and it's leaning against the side of a house. So I think the first thing that I would do is take that description and draw it. So I have a house. Let's make a house. Here's a house. It's a happy little house. There's a chimney, some smoke coming out, and a window. And we're leaning a ladder up against it. So now I've drawn just a ladder leaning against the house. Now let's look at the numbers they gave us. They told us that the ladder is 20 feet long. So I have to think about where that 20 is going to go. Is that 20 going to go here? Is that 20 going to go here? Well, it's the length of the ladder, and this is the ladder. So I'm going to put 20 right there. So that's 20 feet. And hopefully the edge of my house is a right angle. Otherwise my house is crooked. Well, my house looks kind of crooked, but it's not supposed to be. I'd like my house to be nice and straight, so that should be a right angle right there. And my ladder is 20 feet long. All right, now it says this. We've got an 80-degree angle, and it says the angle of elevation. So we need to know about angle of elevation and angle of depression. So here's some definitions that we need to get. So angle of elevation looks like this. It means if I'm standing on the ground and I am looking up at a building, the angle of elevation means the angle from horizontal. That's the angle of elevation. So angle of elevation is from horizontal. The other thing I can have that's good to know is the angle of depression. So angle of depression means this time I'm standing on top of the building. So I'm up here, I'm going to make myself a little smaller. I'm standing on top of the building, and I'm looking at somebody standing down here on the ground. So my angle of depression means it's also from horizontal. So if I was just looking straight out at the horizon, so that makes horizontal because I'm looking at the horizon, then I measure the angle going down to where this person is standing. So this angle right here, that's the angle of depression. So an important thing about angle of elevation and angle of depression is that both are measured from horizontal. So angle of elevation, here's my horizontal, and I measure the angle as I'm looking up. And angle of depression, here's my horizontal, and I'm measuring that angle as I look down. So that's angle of elevation and angle of depression. Now, the problem tells us that it's the angle of elevation that's 80 degrees. So the important thing is that angle of elevation is measured from horizontal. So in my picture, where's horizontal? Here's horizontal. So the angle from horizontal, that can't be this angle because this angle is vertical. So horizontal means this angle. So they're saying that this angle right here is 80 degrees. Which is good because I think if I had 80 degrees up here, my ladder would not be very safe. So now I know that this is 20 feet and this is 80 degrees. Now let's look at what the question asks. It says, find the height of the ladder. Find the height from the top of the ladder to the ground. So I have to think where that is. We're going from the top of the ladder to the ground. Well, where's the top of the ladder? Here. Where's the ground? Well, it's all around here, but I want to go from the top of the ladder to the ground. So it's probably this height right here. So this is what we want to find out is x. So what we really want to know is how far up the wall did we reach? So if we're trying to reach a window up here, do we know if we're high enough to reach that window? So now we have our triangle set up. And with these word problems, what you're really doing is you're drawing a picture of what the situation is. So we drew a nice picture. And then the key is, where is the right triangle? So our right triangle is right here with where the ladder is falling against the house. And then we need to find out where are the numbers going. So we've got the 20 feet long, we've got the 80-degree angle of elevation, we had to know what that means, and we're trying to find, you need to identify what are we trying to find, the height from the top of the ladder to the ground. That's the x, because that's what they're asking us is a question. So that's the first step, is we've drawn a right triangle and we've labeled it. Now the next thing we need to do is we need to identify the sides in the problem. So the easiest one to identify is always the hypotenuse because it's across from the right angle. So if I go across from the right angle, I know this is my hypotenuse up here. Now on this side, I want to know what side of the triangle that is. So I look at the angle and I'm across from the angle. So the side that's across from the angle is the opposite side. And the leg that is part of this angle, that's my adjacent side. It's the one that's right next to that 80 degrees, but not the hypotenuse. All right, so now I know what hypotenuse, opposite, and adjacent are. The next step is I need to decide which of these two sides are important to me. In a right triangle problem like this, there's going to be two sides that are particularly important. The side that they gave me is important because that's the information that I know. So in this case, that's the hypotenuse. The side that I'm trying to find out, that's also important. So that's the opposite side, that's the x. So I want to identify what's the given side and what's the unknown side. Then I want to look at what sides those are. They are hypotenuse and opposite. So now I have to think about my sine, cosine, and tangent and say, which one of those, sine, cosine, and tangent, which one has opposite and hypotenuse in it? So if you think for a while, you might remember that the sine of theta is equal to the opposite over the hypotenuse. So the sine has opposite in it and hypotenuse in it. Therefore, I'm going to use sine, because that has the two sides I'm interested in. I always start by writing just this because for one thing, it gives me a place to start. And for another thing, if I write the formula every time that I use it, then just by writing it so many times, I'm going to remember it. I have to memorize those three formulas. So if I just write them every time I use them, I will eventually memorize them without having to do extra work. If that doesn't work for you, make flashcards or use a mnemonic or sing a song, something you like. So here's our starting point, and now we can say for the theta, that's this angle right here, the 80 degrees, that's the theta. So we're going to say sine of 80 degrees. So theta is the angle. And then we're going to say that equals opposite over adjacent. So the opposite side, opposite over hypotenuse. So the opposite side is x, and the hypotenuse is 20. Now we need to solve this equation. So to solve the equation, we have to pay attention to whether the x is on the top or on the bottom. We like it when the x is on the top because it's easier to do. All I have to do is multiply both sides by 20. So I'm going to multiply by 20 on this side and times 20 on this side. And then I'm going to have 20 sine 80 degrees equals x. Now, I'd like to know the exact value for x, so all I have to do is take this 20 sine 80 and plug it into my calculator. Now I've gotten my calculator, and we need to do this 20 sine of 80. So the first thing we're going to do anytime we're using sine, cosine, and tangent, we want to notice that this angle is measured in degrees. Now my calculator can work in degrees or radians. So we're going to look at the mode and make sure it says degrees. If it said radians, like that, I would have to change it. So I would scroll down, select degrees, and hit enter, and now it's set for degrees. And now I can just quit out of there. Now I just put 20 sine 80 degrees. So 20 sine 80, close parentheses. You don't have to close that parentheses, but it's a good habit. And then we hit enter, and it's 19.69. We should look on the problem if it says anything about rounding, but my problem does not say what to round to. So I'm just going to arbitrarily pick 3 decimal places and say that 19.696 is approximately equal to x. And that is the answer to my problem. So now we've got this answer and we need to look at what it means in terms of this problem. We really have the answer, but we should make sure that we really have answered the question that the book has asked. So The book asks to find the height from the top of the ladder to the ground. Now we've found x. What's x? It's the height from the top of the ladder to the ground. So we've answered the correct question. We should also check to make sure our answer makes sense. This says that it's a 20-foot ladder and it reaches 19.7 feet up the wall. Almost 20 feet up the wall. Now, from my picture, it sort of looks like maybe this should be much less than 20 feet. But we have to remember that an 80-degree angle is actually probably much steeper than that. The 80-degree angle probably looks more like this, so that if it's 20 feet here, it's almost 20 feet here. So our answer of 19 feet makes sense. It's always a good idea when you're doing a word problem and you have a nice picture, make sure that the answer that you get makes sense for the problem. And then the last thing we're going to do is write a nice sentence to answer the question. The distance from the top of the ladder to the ground is, let's call it 19.7 feet. Nice sentence for our answer, and then we're done. So this is the same calculation using the Casio calculator, and it is mostly the same. One thing we're going to notice with the Casio is that it says up the top, it says math, rad, normal, a couple other things. This rad, we don't want it for this problem because this rad means radians. So to set this calculator for radians, we go to setup. So we do shift setup. And then we're going to go down to where it says angle rad. So we're going to scroll down to where it says angle rad. And then off our menu here, we pick degrees. So that's F1, we pick degrees. Now it's set degrees. We hit enter. Now it says DEG instead of rad. So now I know I'm in degrees. Now the rest of it goes exactly the same as the TI. I just do 20 sine of 80. So I'm going to put 20 sine of 80. And I'm going to close my parentheses. Oh, on this one, I guess we don't have parentheses, huh? All right, 20 sine 80, and then we just